We're going to be doing some trig derivatives. I think we already know a few, that when you have y equals sine x, you know that the derivative of sine x is cosine x. When you have cosine x, the derivative is negative sine x. And when you have tangent, the derivative is 1 over cosine squared, or secant squared x. So we want to find 3 more derivatives. We want to know what goes on if we have cosecant of x, what goes on if we have secant of x, and what goes on if we have cotangent of x. Now I could show you those 3 rules real quick, but I want to show you where they come from because I think getting them is not very difficult. So I'm going to show you the 3 rules, but let's start off with finding the derivative of cosecant of x. I know that cosecant of x is 1 over sine of x. So if I want to find the derivative, I can do the quotient rule with 1 over sine x, or I could rewrite this as sine x to the negative 1. Not to be mistaken with arc sine, that is different. I'm just going to use the chain rule here, so we have negative sine x to the negative 2 times the derivative of the inside, which is cosine of x. And then if I rewrite that, that's negative cosine x, and then this is on the bottom, sine of x squared. Now this works for the derivative. I will tell you that things are written a different way. And so let me show you how it's written. It's written as cosine of x over sine x. And then there's another sign that's on the bottom. This is cotangent. And this is cosecant. So the derivative of cosecant is negative cosecant x cotangent x. And it's because you can simplify it that far. Okay, let's look at secant of x. So if you have y equals secant of x, that is the same as 1 over cosine x, or cosine x to the negative 1. Same kind of process, but I think it's good just for you to see the process. So you have that the derivative is negative cosine of x to the negative 2 times the derivative of the inside, which is negative sine of x. The 2 negatives can multiply, and we have sine x over cosine squared of x. I'm just going to write cosine of x twice here. So that's tangent. And then 1 over cosine is secant. So the derivative of secant of x is secant of x times tangent of x. And then the last one, cotangent of x. This one's very similar to finding the derivative of tangent of x. I know that that is the same as cosine of x over sine x, so we're going to use the quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. This is negative sine squared of x minus cosine squared of x. You can factor out that negative 1 on top if you want to get sine squared of x plus cosine squared of x, which comes out to be negative 1. And then negative 1 over sine squared of x is the same as negative cosecant squared of x. So, now that we know the rules, let's talk about how you use them. You really don't have to do 1, 2, and 3 again, but I wanted you to see where those derivatives come from. So now we're just going to use the rules to answer some questions. So let's say that you have y equals x times secant of x. Alright, so we want to use the product rule here. And so we have first times the derivative of the second. Okay, the derivative of secant is secant of x times tangent of x plus the second times the derivative of the first, which is just 1. If there's something in common, go ahead and factor it out, which in this case there is, and that's what you would get for that problem. Alright, let's say that we have y equals cosecant of x minus cotangent of 3x. Alright, the derivative of cosecant of x is negative cosecant x cotangent x. The derivative of cotangent of 3x. Well, cotangent is negative cosine squared of x. Those two negatives will make a positive. Cosecant squared, of 3x. But then you multiply by the derivative of the inside, continuing to do what we know about other rules. So we multiply that by a 3. And then there's the derivative of that one. Alright, let's say that we have y equals tangent of secant of x. And we're going to make that tangent squared. Alright, anytime that you have a trig function that is squared or cubed or whatever, I usually rewrite that and put the squared on the outside, just because I think it's easier to see how to do the process. We're going to be using the chain rule, and sometimes without the 2 on the outside it's hard to tell that you're going to use the chain rule. So we're going to do the chain rule. The 2 will come in front of the tangent secant of x. That's to the first power, so you can have that first if you want, and then times the derivative of secant. The derivative of secant is secant x tangent x. And then that's all you can do. You cannot combine these in any way because this is tangent of secant, and then secant and tangent are separate. Alright, let's say that we have this problem. Y equals cosecant of 3x squared. Alright. The derivative of cosecant is negative cosecant of x, so our 3x squared goes there, times cotangent of x, or 3x squared. And then we multiply by the derivative of the inside, which is 6x. You do not have to have a 6x on both things. It all goes together. And you can put that 6x up in front just to make it look prettier, and that's more simple, like you would probably see on certain problems. Okay, let's talk about the difference in what that problem means and what that problem means. These two problems mean something different, even though there is a 3x. Notice that the squared here was only on the x. This squared is on the whole thing. I could have written that squared like I did here with the tangent. It could have been on the secant. We're going to do chain rule, kind of like we did up there with tangent. So 2 secant 3x to the first. Then we multiply by the derivative of secant of 3x, which is secant of 3x, tangent of 3x. And then one more chain, the derivative of the 3x, which is 3. So then we have 6. Alright, and then we have both of these secants. They're both of 3x. We can combine that and make secant squared of 3x. And then we have our tangent of 3x. Okay, so what if we have square root of cosecant of e to the x? So we can combine all these rules that we've been using. I would think of this as cosecant of e to the x to the 1/2, and then do the chain rule. 1/2 cosecant e to the x, subtract 1, so negative 1/2, times the derivative of the inside. Derivative of cosecant is negative cosecant of e to the x, and then cotangent of e to the x, times the derivative of the inside, which is times the derivative of e to the x, so there's another e to x there. Only other thing I can combine these negative 1/2 and e to the x. And then there's really nothing else that you can combine here. Sorry, let me move that up a little bit. This part right here could come to the bottom if you wanted to, otherwise it can just stay like it is. Alright, one more problem just to talk about. So let's say that we have cotangent of 4x. And to make that fun, we're going to put an ln of tangent in there, just so that it has a couple different things to think about. Okay? So the derivative of cotangent is negative cosecant squared of 4x times the derivative of 4. Now let's talk about natural log. The derivative of natural log of something is 1 over the something, so something over tangent of x, times the derivative of tangent x. I'm just going to put that on the top, which is secant squared of x. And so that's what you get. Only thing you could maybe do is put that negative 4 up here in front to make it look prettier. And so basically with trig functions, it's just knowing a few more rules, but processes are still the same as far as chain rule, quotient rule, product rule, and all of the other rules still apply.